In this lesson, we are going to define and calculate work done on an object by an individual force. Okay, so it is defined as the product of the force and the displacement of the object in the direction of the force. Okay, so in symbols, this one is the work done on an object by a force, and this is the force parallel to the displacement, and this one delta x is the displacement itself. Okay, so this is the explanation again. W is the work done by force F on the object and is measured in joules, and F is the force acting on the object in newtons. Delta x is the displacement of the object in meters. Please note that only when the force and displacement act on the same plane is work done, and work is a scalar quantity, and the SI unit of work is a joule, like I said, and a joule is also equivalent to a Newton meter. This is coming from the formula. Remember, I just told you that work is force multiplied by displacement. The force is measured in newtons, and we multiply this by displacement of the object, and this is in meters. So a Newton meter is just a joule. Okay, these are equivalent to each other. Okay, so let us look at this setup here. This is a kitchen. Let's say you wanted to sit on this chair here. Okay, because the chair is closer to the table, you want to move the chair first. Okay, so you are going to move the chair from this point, let's call it point A, and you are going to move the chair in this way. This is going to be point B. So the chair, if you apply a force F on the chair is going to move from point A to point B. Okay, this is going to be causing the displacement of the chair. Now notice that the chair is going to move in the direction of the force. Then the product of the force that you apply on the chair and the displacement of the chair is going to be work in joules. Okay, so this is going to be work done by the force in joules. Please note that only if the force is able to move an object is work done. Okay, if there is no displacement, then there is no work done on the object. Okay, so let's look at this example. So let us say you wanted to move this block from point A. This is where it is right now. This is point A, and this block is going to be moved to point B, and the block moves a displacement of 4 meters. Okay, so this is caused by you exerting a force of 10 newtons on the block. Okay, so to calculate the work done by the force, we are going to write down the formula. So the formula is F parallel to the displacement multiplied by the displacement, and it is going to be 10 multiplied by 4, and if you work this out, this is 40 joules. Okay, so the work done on the block by the force is 40 joules. Okay, so now let us say we have a different setup here. So our setup, we have the same force, okay, of 10 newtons, and applied on the same block, but now we are applying this force 30 degrees above the horizontal. Okay, so notice in this setup, in this case, the block is still going to move from point A to point B. Okay, so let's say the block moves 4 meters to the right. So the displacement of the block is 4 meters. This is delta x equals to 4 meters. But this is how you apply the force. You are applying the force some angle theta above the horizontal. So they are not in the same direction. So this force now is not parallel to the displacement. So what do we do in this case? Because to calculate work, the force must be parallel to the displacement. Remember that if a force, let's say this is the block, and let's say this is our force, and this is 30 degrees. Okay, so this is how we apply the force on the block. The force has two components. Okay, so I hope you already know that the force, if it is applied at an angle like this, it has two components: a vertical component, let's call it F subscript y, and a parallel component, let's call it F subscript x. Okay, so parallel component meaning it is parallel to the displacement. Okay, so which one of the two, is it going to be Fy or is it going to be Fx? It's going to be doing work on the object. Remember, by definition, the force has to be parallel to the displacement. Out of the two, it is Fx that is parallel to the component. So what we are going to do, we are going to calculate the magnitude of Fx here. The formula to calculate the magnitude of Fx is the force itself multiplied by cos of the angle. Okay, so the force is 10 newtons, and this is multiplied by cos 30. Okay, so if we round off the answer to 2 decimal places, we get 8.66 newtons to the right. Okay, so this is the force that's going to be doing work. So this one is going to be doing work, and this one is not going to be doing work because it is not parallel to the displacement at all, but rather it is perpendicular to the displacement of the object. Okay, so with this we can go ahead and calculate the work done by the force F. So the formula is we take the force parallel and we multiply it by the displacement of the object. Okay, so this is going to be 8.66 multiplied by 4, and the answer to this is 34.64 joules. This is 34.64 joules. Okay, so this is now the answer. So what we have done, we have answered the question in 2 steps. Okay, number 1, we calculated the parallel component of the force, and then we used that parallel component of the force to calculate the work done on the object by the force. So now please note that we have answered this question in 2 steps, but we can combine the 2 steps like this. Okay, so the formula to calculate the work done by a force on an object is the force multiplied by the displacement, but the force has to be parallel to the displacement. Okay, so we agreed. So I just told you that that force will be the parallel component, which is Fx, and the formula for the parallel component is F cos theta. Okay, and multiply this by delta x. From here we can arrange this and we can write F delta x cos theta. Okay, so it means the work done by a force on an object is going to be the force multiplied by displacement multiplied by cos theta. You will find this on your data sheet at the back of your question paper. Now we can calculate the work done by the 10 Newton force using the formula I just showed you. Okay, so the formula is going to be F delta x cos theta, and we can substitute the force as 10. The displacement is 4 multiplied by cos of 30. If you put this in your calculator, you are going to get 34.64 joules. Okay, so this takes us to the end of our lesson. See you on the next one.